Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about section of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So this lecture is regarding the solid which is being cut by a section plane which happens to be inclined to the horizontal plane and perpendicular to the vertical plane. That is, here we have an auxiliary inclined plane, that is the nature of the cutting plane is AIP. So this cutting plane happens to be inclined to the horizontal plane at an angle theta, whereas this cutting plane is also perpendicular to the vertical plane. So here we have one example over here, that a solid is being cut by an AIP which is inclined to the horizontal plane. So this portion of the cut solid will be discarded or thrown away, and this remainder portion of the solid is left with us. Now, when we are looking at this cut solid in the front view, we are going to observe the edge view of this cut section in the front view. Whereas, if we are looking at this surface from the top, that is, this cut section is being looked by the observer from the top. So the projections which are obtained on the horizontal plane in the top view, they will only represent the shortened view of this cut section. That is, we are going to get the section top view showing the apparent shape of this cut section. So if we have to observe the true shape of this cut section, then we need to draw another auxiliary inclined plane parallel to this cut section or the cutting plane, and the projections obtained on that AIP, auxiliary inclined plane, that is, in the auxiliary plan we will be able to observe or evaluate the true shape of this cut section. Now this is the problem that we are going to discuss today. So we have got a square pyramid. Just see, this is a square pyramid which has been cut by a cutting plane passing through all the four slant generators over there. These are all four slant generators. So all the four generators are being cut by this cutting plane. So this cutting plane is inclined at an angle of theta with respect to the horizontal plane, while this cutting plane is perpendicular to the vertical plane. Now if we look at this particular solid, you see, so this is the top view, which is going to be a square which will be drawn onto the horizontal plane because the solid is resting on its base on its horizontal place. Now since the solid is resting on the horizontal plane, so we get the square as the true shape in the top view. Now this is the front view of the solid. Now as we have seen over here, that this solid is being cut by this cutting plane which is inclined to HP and perpendicular to VP, that is AIP. So we are going to get, you see, 4 points of intersections over here. So the 4 points of intersections corresponding to the 4 slant edges of the square pyramid, they will be observed. But when we are going to look at the front view of this particular cut solid, the edge view of this cut surface is visible over here. But when we are going to look at this top surface from the top, then the view which is obtained in the top view on the horizontal plane will reveal the apparent shape of this solid. So this is the section top view, and we are not going to get the true image or true shape of this cut section in the top view. Why? Because this cut surface or the cutting plane happens to be inclined to the HP. So since the surface is inclined with respect to the HP, so the projections on HP, they are viewed as the apparent shape projections over there, which are shorter than the true shape projection. Now in order to obtain the true shape of this cut section, we need to go parallel to this cutting plane, that is another AIP we have to draw, and from these 4, you see, points of intersection, so the projectors will be drawn onto the AIP. So the projection on AIP, that is your auxiliary plan, is going to give you the true shape of this cut surface over here. So let us now read out the statement and work out the projections from the scratch. So we are given that there is a square pyramid having a base 40 millimeter side, axis height is equal to 65 millimeter. It is resting on its base on the horizontal plane. So the top view of the square base will be obtained onto the horizontal plane. So let us see in which orientation we have to draw it. So this top view will be drawn below the XY reference line, and it has got two edges of the base perpendicular to the vertical plane. So you can see in this view, none of the edges, they will be perpendicular to the vertical plane when we are going to draw this view below the XY reference line. But if we draw this view over here below the XY reference line, two of the edges of this square pyramid will be lying perpendicular to the vertical plane. Then it is cut by a section plane which is perpendicular to the vertical plane and inclined at an angle of 45 degree to the horizontal plane, bisecting the axis. Just see, this is the axis of the square pyramid. So this is the top point of the apex or the axis. This is known as O dash. This is bottom point of the axis, that is on the base. So this point will be called as O1 dash. So this axis is being bisected by this cutting plane, right? So we need to draw the sectional top view and the true shape of the section. So let us work out the projections of the solid. So here we have the XY line. Now we are going to draw the top, that is the top view of the base of the square pyramid. So this will be a square. Edge of the base is 35 millimeter over here. So this we have drawn, and now we are going to mark all these points. So A, B, C, D happens to be the base of the square, the edges of the base of the square, and then you are going to join both of these diagonals over there. The moment you join these diagonals, the points O and O1. O point is the point of the apex or the vertex which is there, that is top point of the pyramid, whereas O1 is the base point, which is base point of the axis of the pyramid. Now let us draw the front view projections. So in order to draw the front view projections, we are going to look from this side. So since the base of this pyramid is resting onto the ground, so the front view projections from B and E, once you draw the projector through B and A, they will be meeting the vertical plane on the XY reference line. So you get the projections B dash and A dash on the XY reference line. Similarly, the projectors through C and D, they are going to intersect the vertical plane on the ground, that is at the point C dash and D dash. So these 4 points of the base and the axis point O1 has been located over here. This is the O1 dash at the base over here. Now I am going to mark the axis height. So the axis height is given to me as 60 millimeter. So once I draw the 60 millimeter height, so this gives me the location of the point O dash. And now I am going to join the slant edges O dash A dash, O dash B dash, O dash C dash and O dash D dash. Now we must remember that the projection of the projector OA, so in the front view this will be dotted because this slant edge is lying on the back side, but its dotted projection, that is the hidden line projections of O dash A dash, they will be coincided or superseded by the solid line or object line projections corresponding to the slant edge OB. So OB projector in the front view, that is O dash B dash, will be solid line, whereas the projectors of O dash A dash will be dotted. But O dash B dash projectors, they are going to overshadow or coincide with the dotted or the hidden line projections of the OA in the front view. So O dash A dash will be superseded by the projections of O dash B dash. Similarly over here, the projectors of OD in the front view, that is O dash D dash, will be dotted because this edge is lying on the back side. But these slant edge projectors in the front view will be overshadowed by the projectors of the slant edge OC in the front view. That is OC means O dash C dash projectors will be dark lines, whereas O dash D dash projectors will be dotted. So these dotted lines projectors of O dash D dash will be superseded or coincided or overlapped by the solid line projectors of the O dash C dash slant edge. So having drawn the front view and the top view, now we need to locate the cutting point for my cutting plane. So cutting plane is bisecting the axis. So this is my axis O dash and O1 dash over here, and then this is my center point, and through the center point you see a cutting plane will be passing, which is going to bisect this axis, and the position of this cutting plane is AIP, that is in perpendicular to VP and inclined to HP at an angle of 45 degree. So this cutting plane cuts all the 4 slant edges over there, thereby yielding 4 points of intersection. You see, 2 points of intersections will be lying on this projector line, and 2 points of intersection will be lying on this projector line. So we are going to name these POIs as 1 dash, 2 dash over here. That is 1 dash is the point of intersection of the cutting plane with the front view projection of the slant edge O dash A dash. So O dash A dash has been cut by cutting plane at the point 1 dash. Similarly, O dash B dash projection in the front view has been cut by the POI, that is point of intersection 2 dash by the cutting plane. So now what I need to do, I will be drawing a vertical projector from here. So wherever these projectors they intersect OA and OB, I am going to get points 1 and 2 located over here. So let us start. Since 1 dash is the point of intersection of the cutting plane with the front view slant edge O dash A dash, so I am going to bring this projector down. So wherever it intersects with the top view projection of this slant edge OA, I get the location of the point 1. Similarly, 2 dash is the point of intersection of the cutting plane with the slant edge O dash B dash. So once again I draw the vertical projector through 2 dash, and then wherever it meets the top view of the projector for this slant edge, that is OB, I get the location of point 2. Similarly, 3 dash and 4 dash are points of intersection of the cutting plane with the slant edges O dash C dash and O dash D dash. Now let us start. Once again I will be bringing one projector down. So once I bring this projector down, vertical projector through 4 dash and 3 dash. So let us start with 4 dash now. So 4 dash is the point of intersection of the cutting plane with the slant edge O dash D dash. So 4 dash point lies on O dash D dash. So I have brought it down. So wherever it intersects with the top view of this slant edge projector, that is OD, I get the location of point 4. Similarly, 3 dash is the point of intersection of the cutting plane with the slant edge in the front view, that is O dash C dash. So again I am going to bring this down. Wherever it intersects with the top view of the OC projector or the slant edge over there, I get the location of point 3. So all the 4 POIs in the front view as well as in the top view, they have been located. But one thing I need to remember, because this slant surface, that is the cut surface or the section surface, happens to be inclined to HP. So the view which I have obtained over here, this will be the sectioned top view. So this is not the true shape, but this is the apparent shape of this cut section, which is represented by 4 POIs, 1 dash, 2 dash, 3 dash and 4 dash over there. Now let us join the uncut portion of the solid. Remaining portion of the solid in the front view will be this one, while this portion has been cut out and it has been discarded, right? So similarly, the top portion of the remaining solid, it has been joined. So the base has been joined and the remaining slant edges, they have also been joined appropriately. So this completes our front view, which is the sectioned front view. This completes the section top view, and this sectioning that we have done, it is going to reveal the apparent shape of the cut section. So we call it section top view. Now let us work out the true shape of this cut section. So here you can see, here we have couple of POIs over here, couple of POIs, they are lying over here. Now we are going to draw an AIP which will be parallel to this cutting plane. So this AIP has been drawn x1 y1 parallel to this cutting plane. Now the projectors through these 4 POIs, they will be drawn onto the auxiliary plane x1 y1, and whatever projections over here will be drawn, and the name of these projections is auxiliary plan. because projections obtained on AIP, they are called auxiliary plan. And since these are the auxiliary plan projections which need to be drawn, now the distances of the plan for the 4 points of intersection, they will be measured over here. That is, the distance of point 1 from xy will be measured. It will be transferred in front of x1, y1 on the locus line of the POI, that is 1 dash and 2 dash over here. Similarly, the distance of point 2 from the xy reference plane will be measured, and again it will be transferred over here. So let us do it. This is the transferring of the distance of point 1, you see, from the xy reference line, right? This is the xy reference line. So from here I am going to measure the distance of the POI in the top view. So this was point 1. So after measuring this distance, this has been transferred over here. So the name of this point is 1, 1. Now I am going to measure the distance of point 2 from the xy reference line. So this distance is measured, and on this locus line of 2 dash, again I am going to mark this point 2, 1 over here. So this is the distance which I have measured and marked corresponding to this distance of point 2 from the xy reference line. Similarly, corresponding to the point 4, you can see I am going to measure this distance of point 4 over here, and onto the locus line of POI 4 dash, from x1, y1 the same distance will be transferred. So name of this point is 4, 1. And finally I am going to measure the distance of point 3 from the xy reference line, and once I measure this distance, I am going to transfer this distance ahead of the plane x1, y1 over here. So this point's name is 3, 1 dash. So all the 4 points, they have been evaluated: 1, 1, 2, 1, 3, 1 and 4, 1. So these are all points which correspond to the distances of all the POIs in the plan with respect to the xy reference plane over here. Now after evaluating this particular true shape of this sectioned view, you see this was the sectioned surface over here. So since this section surface happened to be parallel to this auxiliary plane x1, y1, so the image or the projection which is obtained in the form of auxiliary plan onto the AIP, this will be called true shape of the cut section. So here you can see this true shape of the cut section. This is bigger than and broader than the apparent shape which we had obtained in the first step. So the true shape of an object will always be greater than the or bigger than the apparent shape of the object over there. So with this, using the principles of projections of solids, sectioning of solids and the auxiliary planes, we have been able to evaluate front view of the section solid, top view of the section solid and the true shape of the cut section which was required in this particular case. So thank you very much. Thanks a lot. Thank you.